So the next talk will be, well, it's already been mentioned a few times, about DBT and also about, well, the question to DBT or not to DBT. So zooming out a little bit, it's about more generically, which tools do we use to do data analytics, right? Which tools do we use to actually process data? And let's maybe start with a slide that has some logos on it. And I want to start also by asking a question. So, which of you have heard about DBT? That's quite a few hands. Which of you have heard of one of the other four, or know what one of the other four logos are on this slide?
Does it count if you told me?
Does it count if you?
If you told me.
Yeah, you can. Yes, but okay, indeed, it's much less well known. These are some of the competitors of DBT, or tools that you could consider competitors in some way that we will talk about during this slide, during this presentation. But indeed, the first point I really wanted to make, in the world of especially of SQL data analytics, DBT is really the king. It's really by far the largest in terms of number of users, in terms of financially how successful they are. If you look at their direct competitors, it's really quite big. Now, let's maybe start by asking the question, why is that? Why is DBT so popular? So it's a tool to do, basically analytics with SQL, and that's actually, it has a very low barrier to entry. You can actually write just SQL and get started with DBT, right? You can just write SQL queries, which you put in code, and then DBT will run those queries. And you don't actually need to do anything more than that. There's more features, there are more things you can do with DBT, but all these other features are optional. You really can just get started putting some queries, SQL queries as code in some code files and just have DBT run those automatically. Now, of course, that by itself would not be enough to get traction. Now, another reason why DBT is so popular is it does enable working with SQL with all of these good software engineering principles that were just discussed, and all of these I won't go into detail again, but all this modularization, dry code, don't repeating yourself, the version control, all these environments, that are things that are enabled by using DBT. You don't have to do all of these things at the start, but you can gradually grow into them, and you can use all of these good software engineering principles. And a last one is it also, and this ties back to the talk of Jelle, you can also do easy data testing, and nowadays also actually do data contracts. This is also part of DBT. You can actually just by writing one single line of code, check things about your data and run these tests automatically. So the automatic testing of data, that's also referring back to Jelena's talk, these are things that are possible with DBT. So that's why DBT is so popular, but we'll also be looking at some of the competitors of DBT, and we will look at 4 competitors of DBT in this talk. So we will look at 2 SQL-based competitors, which is SQLMesh and SDF, and then we will also look at 2 Dataframe API-based competitors or tools that integrate with DBT in some way, and those will be IBIS and Snowpark. But first, let's start with the first one, SQLMesh. What is SQLMesh? SQLMesh was introduced 2 years ago by a blog post called A DBT Killer is Born. Now, 2 years later, if you look at the number of website visits that they receive, it would be kind of hard to call it an actual DBT killer. It's like almost only 1%. But still, nevertheless, it's actually we should not disregard it entirely, because they actually have 2 fundamental differences or new ideas that they bring to the table, which are very useful. One is a concept called virtual data environments. And this concept means that instead of writing data directly to the place where consumers will read from it, it's written to internally managed tables in some internal schema that SQLMesh manages itself. And then the output schema contains only views on that data. So what that actually enables is this concept that Jelle was talking about, this write, audit, publish pattern, even if your data warehouse does not support fancy things like iceberg swapping of the metadata files. Even if you just have a simple data warehouse, it actually, by doing it, by writing the data to an internal schema, you can do the write, audit, publish pattern where you first write your data to some internal table where nobody will be able to read from it. Then you do the audit, you run all your tests, and only at the end, if you are sure that all your data is correct, then you publish the data by updating those views. And this is almost instantaneous or very quick, and then people can read from it. This is in contrast to DBT, where if you want to do the same thing, you actually have to do a lot of manual work, but the default way in DBT is actually write, publish, audit, right? So you write directly to the tables where your consumer will also read from it. By doing that, you're also immediately publishing it. And then, yes, you can do these tests, but if your tests then detect that something goes wrong, that something was incorrect, well, it's already too late. So maybe you should actually extend it, write, publish, audit, panic. If something goes wrong, it's kind of already too late, and you have to go back and fix or detect what's wrong. So that's sort of an interesting concept of SQLMesh and a good new idea that they bring to the table. A second good new idea is that they say they have a semantic understanding of SQL. So this semantic understanding, what it means is that, well, in contrast to DBT, where SQL is just text. If you have a query, DBT will not try to parse that query or understand it. It will just give it to the data warehouse, you deal with it, and if you get back an error message, it will not know what to do with it other than just to display the error message and say, okay, I don't know what this was, but SQLMesh will actually try to parse the structure of this query, and then it will actually try to understand what's going on. And by itself, okay, why do I care? What does this semantic understanding bring me? It brings three things. For one, it brings the detection of invalid SQL locally, so you can write a query and then, or a model, and then already SQLMesh can tell you, before even sending it to the data warehouse, hey, the SQL is wrong, you're missing a comma here or there. But even more powerful, since it structurally understands what your query is doing, it can even translate the SQL query that you're writing to a different SQL dialect, such as DuckDB, and then it can run your query. It can execute the logic that you just wrote in this query, for example, DuckDB, and you can do that for unit testing. So you can use a query, you can use DuckDB to actually run the unit tests that you've written. That's a very powerful, a bit scary feature, because maybe the translation isn't perfect, so this is a bit scary. But the last one is column-level lineage. So it understands how the input is transformed into the output. It can then also visualize that column-level lineage. Right? So those are three features being brought by semantic understanding. Zooming back out to the whole story, DBT has also been noticing these changes, even by their smaller competitors. And they have done several things which you could say maybe they were a response to these things from SQLMesh. And one is, well, column-level lineage. Actually, DBT does have column-level lineage. They introduced it in February last year, but it's not quite the same. So in DBT, if you have macros and complex logic that generate SQL, the DBT will only parse the output of your compilation of SQL queries, whereas in SQLMesh, it really understands everything structurally, including all the macro calls and logic that generates the SQL. So it's an extra level of semantic understanding. Another thing that maybe you have heard that DBT has is this concept of a semantic layer, which they introduced in October of 2023. And that's, okay, the concept there is, maybe we don't understand arbitrary SQL, but what if we define our own semantic models in YAML instead of SQL, where we define some sort of predefined structure in a proprietary language, then we can at least understand that. So it does allow for an understanding of what the model does, but you cannot express any arbitrary logic in it. It's restricted to dimensional time series data. So it brings some of the aspects of semantic understanding, but not all of the aspects. So okay, the column level lineage is sort of a weaker version. Semantic layer is sort of also a weaker version of what SQLMesh brings. A last thing they did, and you may have seen this if you were paying attention to blog posts in around January of this year, so very recently, they actually bought a competitor which does have some of these features. And that competitor is SDF.
Yes, SDF. Where does that stand for? Let's try to Google that. Actually hard to find. Syrian Democratic Forces sign distance function. But in the end, we get there, SDF Labs, that's what we're looking for. Actually, DBT in the beginning was also hard to search for, so maybe it will get better. So where does it stand for? Semantic Data Fabric. That still doesn't tell us a lot, right? And even they admitted in a podcast that it's actually a backronym because it was just easy to type with your left hand. I think you can still use your mouse, although I don't know why you would need a mouse as a data engineer. And what it does, it really looks very similar to SQLMesh in the backend, but it does not only parse your SQL, it really compiles it. So the developers of SDF, they were actually experienced in compiler development. So it goes much faster. And it compiles your SQL just purely logical, and it can do that because it's really fast and written in Rust. So it's kind of like SQLMesh and DBT, it's just much faster. To give you an idea, just getting the version in DBT takes you a while. Like 3 seconds. In SDF, it is like 150 times faster. So written in Rust, you hear that a lot today, and why that is relevant in the current state of data, that is something Michiel will talk about.
So yeah, indeed, like Rust, the programming language, has a reputation for producing tools that are fast, and I think that's also partly one of the advantages of DBT, of Rust. But in general, why do you care that something's written in Rust? Well, I think there are 3 aspects of the Rust programming language that make it produce great tools. And of course, one of those aspects is that it allows for full low-level control, which is what enables this fast performance, right? It's essentially a low-level language in that it gives you full low-level control. For developers, that does mean you have to consider some of these low-level aspects, like memory management. But as a user of a tool that's written in Rust, you actually get all of the benefits of this low-level control and none of the downsides of it. So in this case, yeah, you only get the fast performance. Secondly, Rust has a compiler which is very strict. It checks many things, and that does allow for like very reliable software. The output of your code if it passes the compiler checks by Rust, it results in reliable software. For the developer, it's more work up front to satisfy that compiler, but as a user of a tool, I only get the advantages here again. And lastly, it's also a statically compiled website, statically compiled language. So again, that enables great performance. It also enables easier installation. You just get a single binary that can be installed. This compilation can be slow, so that's again a downside for developers, but well, as a user of a tool written in Rust, you get all the advantages. And maybe that's an aspect of why we see that tools being written in Rust, it's not just SDF that's now a tool written in Rust that's gaining popularity. There's actually like really a trend, especially last year, of many tools being written in Rust and gaining a lot of popularity. So one of those that you may have heard about is UV, a Python package manager, which they only started in 2024, but if you compare it to the competitors, pip tools and Poetry, they really, in number of GitHub stars, are exploding and really taking over their space in the market of Python package management. So that's really one of the examples of a popular tool being written in Rust now and gaining a lot of popularity. Another tool is Polars, which was discussed in the previous State of Data last time. And that tool, also if you go to their website, also puts front and center this aspect of it's written in Rust, right? So this really is many tools that really market with the fact like, hey, we are a tool and we are written in Rust. So at least these tools, yeah, they really care about advertising that fact. Now, okay, DBT has acquired SDF, which is also a tool written in Rust. Does that mean that DBT will be written in Rust in the future? It's a bit hard to tell. In their blog post where they announced it, they announced, okay, that the SDF won't be included as part of the open source code base, but we do plan to make meaningful parts of SDF available to all DBT users. Now, what that meaningful parts means, they didn't specify, right? Do we get the semantic understanding? Do we get the Rust-based parser? It's sort of hard to tell, right? So yeah, we will, like, the story is to be continued. This is pretty recent news, but zooming back out, this was talking about the SQL-based competitors to DBT. We'll also be talking now about data frame API-based competitors.
Yes, we don't want to have this talk only resonate with people that write SQL, but I want to do a quick vote. So who is writing SQL and who is Python as their favorite language to do their data transformation in? So who votes for SQL here? And who votes for Python? Data frame APIs, I will call it in this talk. Okay, good. Less SQL than I expected. So data frame APIs. The most read blog post, I think, of our CEO was called "Why DBT will one day be bigger than Spark." And the two main arguments are SQL is easier, so the entry level of DBT is much lower, so it will gain far more adoption. Argument two was, yeah, Spark basically solves a problem that is no longer there. Distributed computing, we can nowadays just have a very big machine with big memory, and you can just write pollers, and that will be faster. And looking to the trends of website visits, getdbt.com actually now has more daily visits than spark.apache.org. Of course, gauging popularity is much more nuanced than just looking at these website visits, but the trend might be going in the right direction. But as a data scientist, I actually don't really like SQL. It's unintuitive. You need nested queries for even the most basic questions that you can ask. So wouldn't it be nice if I can run both DBT and Spark? So that is something that we are going to look at. First tool is IBIS. What is IBIS? Basically, it allows you to pretend you're a SQL wizard, but in the end, you're just writing Python. So you don't have to write any join or merge, and you can just do IBIS to SQL. So you write very easy. Is there a laser pointer? Maybe not. But you can write easy data frame API, and you say to SQL, and bam, no matter what SQL backend, so it supports all the SQL dialects. So no worry about Oracle doing a limit 10 and then all of a sudden it doesn't work. And that is the most compelling thing for me, is just with one line of code, I can change from using pollers as a backend to using Snowflake or BigQuery as a backend. So you can write your PyTest locally, do your modularity, and then only at the last stage you switch to actually use the compute of your SQL warehouse. And then it also integrates with DBT. So you can install the tool DBT IBIS, and then when you run DBT compile, it first does a pre-compilation of your data frame IBIS models to SQL. And then you can just write a simple IBIS file, and then under the hood, it really makes some impressive SQL statements that I would never have been able to come up with. And this also, you can still use type checking in Python and run your test in Python, and then it compiles to SQL. So that is nice. The other competitor or thing that we want to look at is Snowpark. And Snowpark is actually just for me an example of SQL or data warehouses offering their own Python APIs. So not only Snowpark, which is exclusively linked to Snowflake, of course, but also BigQuery has BigQuery data frames, Starburst has PyStarburst, and of course, for Databricks SQL warehouses, you can also still use PySpark. In this way, you don't have to pretend you're writing SQL, because you can just actually execute Python on your data warehouse itself. And that allows you to use the actual compute efficiently of your data warehouse. And that is especially nice if you, for example, want to have some complex tasks, for example, machine learning algorithms that you don't want to write in SQL. And also this nowadays integrates with dbt. So I think like 2023, dbt also allows for Python models. So you can actually now run Spark and dbt in the same project. And why do you want to do that? Well, you can still use dbt as your scheduler, or you might have used some models write in SQL, then some complex models that use some machine learning APIs might use Python and data frame APIs. Also, it's easy to collaborate, and you still have your data test and your documentation and lineage still in dbt. And it's really simple. You just say in your dbt project, language Python, and voila, it works, but it only supports a limited number of backends for now. So, to dbt or not to dbt? That's the question. And what we think is the answer is actually to dbt and not to dbt. And that means that we're still using dbt, but we're not only use dbt, we also use other tools. So we're more flexible and we're not locked in to SQL, but we combine it. So dbt more or less becomes like a foundational layer that actually allows for multiple tools on top. And we saw that 4 times during this talk. SQLMesh integrates actually with dbt. SDF integrates, but is also bought by SDF, by dbt. And then IBIS and Snowpark, they both integrate very well with dbt. So it looks like that to compete with dbt, you first have to integrate very well with dbt. But it gives us as data engineers and data scientists a lot more flexibility than only dbt. So bright future ahead, I hope, and that's it. And I think
we have
there's
time for questions?
Yeah, questions.
Yeah, this is indeed, we didn't have time to go with into Dataform. I haven't personally worked with it. It's as context, it's also a DBT-like tool, which works, I think, only with BigQuery. Yeah, it does. So it's a more limited tool in the sense that if you work with BigQuery or GCP, I think it's a good tool. But since that one is quite limited in scope to only BigQuery and GCP. Yeah, we didn't also go into that one in detail. It was bought by Google, and it at least markets itself in that sense.
Yeah, 2 questions. The first one is, does SDF still continue to get development after dbt has bought it?
No, they actually, like, if you download it, you can still go download it, but they will say there's not going to be further development and new releases.
And the other one is, what is the ranking of like popularity? So like number 1 is dbt, of course. How does it go on from then on? I guess SQLMesh is number 2.
Yes, I would also guess that. Yeah.
They're all very, very distant second place. Like relatively, they are comparable to each other, I think. But it's a very big gap between dbt and all the others that we discussed today.
Yes, Robert?
Yeah,
So it's SQLMesh. Feature I find really cool is that it like can parse SQL and have semantic understanding.
Yes.
But don't you lose then the ability to do macros? With like in DBT, you have these Jinja expressions where you can even dynamically add SQL code based on something in your data warehouse. So how can you, like, do you lose that ability in SQLMesh?
No, in two ways actually you don't. For one, so the difference between a macro in SQLMesh and just a generic macro in DBT is in DBT, the macro is really just doing string replacements. And you can do that still in SQLMesh and also in SDF. You can just say, hey, this is a Jinja macro that should do, you put some sort of like boilerplate around it that says, okay, don't try to understand this model. I want to do just text replacements with this macro. That's possible, but of course then you lose all of these nice advantages. SQLMesh also does have their own way of doing macros, which is then you're actually writing Python code, so it looks almost a bit like compiler transformations. It's less easy to write such a macro than it is to write a DBT macro, but you can still write it and even have the compiler understand it.
And even as complex as DBT macros, where you can query the warehouse?
I'm not sure about that. I think so, probably because the macro is Python code. You can probably even read files and do whatever you want. Your macro really is just code that's being executed. And that code could query your warehouse. So I think actually the answer is yes, yes.
Pascal?
Pascal?
Well, the question is like, as a SQLMesh basically tries to understand what's the native dialect of SQLMesh as it's able to translate to multiple destination systems. Aren't you then limited by the common denominator of all these different SQL systems? How much does it know, for example, in Starburst I have a very specific function that might not completely translate to Snowflake or vice versa?
Yeah, when you configure this, when you configure SQLMesh, you specify which dialect that you're writing in. Typically, you will take the dialect that's also your data warehouse. I don't know if it's necessary to take it, but you specify it. You specify, I'm going to write this dialect of SQL. And then it can, then you can start using like functions that are only available in that dialect. And it will have some level of trying to understand what that function is and maybe how that translates to functions that are not available or different in other dialects.
And in SDF, you actually, if it doesn't know a function, you can say in your YAML, like, these types are my inputs, and this will be the output types or output columns, and then it still is able to parse it.
Will it also be able to generate like common table expressions and stuff like that in the final query?
Yeah, I think
Yeah.
absolutely.
Okay, I don't think there are further questions.